Hello, my dear students and the rest of the learners. Welcome to part 39 of a 41-part series of tutorials in Fundamentals of Object-Oriented Programming in Java. In this tutorial, we are going to be looking at Java polymorphism, which is a characteristic or a feature of object-oriented programming languages such as Java. My name is MemJM, or you can simply call me Emily Swap. What is polymorphism? The word poly means many and morphs means forms, and therefore polymorphism means many forms. Polymorphism is therefore the ability to create a variable, a function, or an object that has more than one form. It enables objects of different classes related by inheritance to respond differently to the same member function call. It occurs when we have many classes that are related to each other by inheritance. Therefore, polymorphism plays an important role in allowing objects having different internal structures to share the same external interface. This means that a general class of operations may be accessed in the same manner, even though specific actions associated with each operation may differ. An operation may thus exhibit different behaviors in different instances. The behavior depends upon the type of data used in the operation. Polymorphism is therefore very useful when you want to reuse the code. Reuse attributes and methods of an existing class when you create a new class. Generally, polymorphism has the following advantages. Number one, it increases code reusability by allowing objects of different classes to be treated as objects of a common class. Number two, it improves readability and maintainability of code by reducing the amount of code that needs to be written and maintained. Number three, it supports dynamic binding, thus enabling the correct method to be called at runtime based on the actual class of the object. Number four, it enables objects to be treated as a single type, making it easier to write generic code that can handle objects of different types. However, some disadvantages of polymorphism in Java include that it can be more difficult to understand the behavior of an object, especially if the code is complex. Secondly, it may lead to performance issues, as polymorphic behavior may require additional computations at runtime. In Java, polymorphism is mainly divided into two types, which are compile time polymorphism and runtime polymorphism. So what is compile time polymorphism and what is runtime polymorphism? Let's look at what we call the compile time polymorphism in Java. Compile time polymorphism in Java. Compile time polymorphism in Java is also known as static polymorphism and is implemented by method overloading. Method overloading entails having multiple functions with the same name but different parameters. The methods can be overloaded by changes in the number of arguments or a change in the type of arguments. This type of polymorphism is implemented in a program by making use of multiple methods having the same name. The following is therefore a sample program implementing compile time polymorphism in Java with use of method overloading called multiply to compute given numbers. So the comment is this is a program implementing polymorphism through method overloading by using different numbers of arguments. The file name is polymorphism.java, which simply means that the name of the class that we are going to use is a polymorphism. Then we have package polymorphism. So this is the name of the project. Then we have input import java.util.scanner. And then our first class definition is class polymorph method. Remember, these are the names I'm just using for the sake of making the program easier to understand, especially for you, my dear students, and the rest of the learners. So the name of my class, the first class, is polymorph method. So this method receives values of two parameters and multiplies them as follows. So we have a method here. This method is called multiply, and it is expected to return a value of type integer, and it is receiving two parameters, parameter A and parameter B, both of type integer. Then once those parameters are received, A and B, this method multiplies the content of or the value in the parameter called A with the parameter or the value in the parameter form B, and the answer or the results are stored in a local variable or a member called answer, who is of type integer. So once that is done, the method called multiply returns the result to the caller as answer. That's what the statement means. So that is how that method called multiply is going to work. It is going to receive two values, multiply those values, assign the answer or the response in the local member, data member called answer, and then return that the content of that memory location called answer to the method which will have invoked this method. Then the next method is for receiving values of three parameters and multiplying them. Note the name. The name for this first method is multiply. It is having return type of type integer and receiving two parameters. Now, if we have the same method called multiply, as you can see, but now it has more parameters. In this case, it has three parameters: parameter A, parameter B, and parameter C. Simply, you can see that this method is looking as if it is a new one. But in real sense, it is the same method with the same name multiply, but it has difference on different number of parameters. So it receives, or three values are received through parameter A, parameter B, and parameter C. When they are multiplied together, the answer or the result is assigned in the local member called answer of type integer. And then the value that is in this local member called answer will be returned back to the caller as multiply. So my dear students and the rest of the learners, you can see the application of several or the application of the same method, same name, but with certain changes, especially in change of parameters. Then we have a second class. So the first class is called polymorph method, and it has, as we have seen, it has two members. These members are called multiply, and they're almost the same. The only difference is that one is making use of two parameters and the other one is making use of three parameters. So the second class is called polymorphism. Now this class is the main driver method. So it is within this class that we have the main method. Now under the main method, we have the following variables declared. That is result, num3, num2, num1, and those variables are of type integer. And then we prompt the user to enter the various values through the input object. So the first statement to be displayed there is enter the first number. The user will key in a value. It will be read by the method called nextInt, and it's going to be assigned through the object called input to the memory location called num1. From there, it will prompt the user to enter the second number. Then the user keys in second number. It is going to be ran by the method called nextInt, and the value will be assigned in the memory location called num2. Next, it will prompt for the next third number. The third number will be entered by the user, and once the user presses enter key, that value will be stored in the memory location called num3. From there, we can invoke the method called multiply by passing different arguments into it. If we invoke multiply, which is under polymorph method, then we are going to send into it two parameters or two arguments, which are the memory location called num1 and the memory location called num2. So those two values will be sent to the method called multiply. And once that is done, the processor will go to that specific method. It will come here, perform these activities, and then send back the response to the main. So that value will be brought to the main, and once it is returned, it will be assigned in the memory location called result. And then the control will be taken to the next step to execute this other statement here. So once this statement is executed, the processor will display the following text on the screen. The result for multiplying, so that text will be displayed, followed by the content or the value in the memory location called num1, followed by the text and, then followed by the content in memory location called num2. And then the text is, and then the content of memory location called result. So if, for example, value 1 is 10, num2 is 15, then what is going to be displayed is the result for multiply 10 and 15 is 150. That's what will be displayed on the screen. Then next, we are invoking the same method called multiply, but this time around, we are sending to it 3. We are sending to it 3 variables. We are sending to it 3 values, which are num1, num2, and num3. It's the same method by the name multiply. So once that is executed, then the processor will go and look for that method. Here is the method, which is making use of 3 parameters. So it will receive the 3 parameters or the 3 values, do the multiplication, assign the answer in the memory location called the answer, then return the value back to the caller. And once that value is brought, the control will be brought at this point. The control will be brought at this point, and the value that will be returned will be stored in the memory location called result. And then the next statement to be displayed on the screen will be the result for multiplying the content in the memory location called num1, for example, 10. Then the content in memory location called num2, for example, 15. And the content in memory location called num3, for example, 9, is it will then pick the content in the memory location called result and display it on the screen. So once that is done, that will be the end of that program. So my dear students and the rest of the learners, that's how we can implement, or that's how we implement this first type of polymorphism, which we are calling the compile time polymorphism in Java. Let's now look at the other type of polymorphism that we have already mentioned. So the other type of polymorphism is runtime polymorphism. So what is runtime polymorphism? Runtime polymorphism is also known as dynamic method dispatch, and is implemented by the method overriding. Runtime polymorphism is a process in which a call to an overridden method is resolved at runtime rather than at compile time. In object-oriented terms, overriding means to override the functionality of an existing method. This type of polymorphism is thus achieved by method overriding. Method overriding occurs when a derived class has a definition for one of the member functions of the base class. That base class function is said to be overridden. So what are the benefits of overriding in Java? One has the ability to define a behavior that is specific to the subclass type, which means a subclass can implement a parent class method based on its equivalent. Therefore, method overriding allows us to achieve runtime polymorphism and is used for writing specific definitions of a subclass method that is already defined in the subclass or in the super class or the parent class. This method, a superclass, and overridden method in the subclass should have the same declaration signature as parameters list, type, and return type. Therefore, Java method overriding is used in Java for achieving runtime polymorphism and writing specific definition of a subclass method, which is known as the overridden method. We can implement Java method overriding by using the super keyword. When invoking a superclass version of an overridden method, the super keyword is used. The following is therefore a sample program that implements runtime polymorphism through method overriding using superclass or super keyword, prompting the user for weekly payment and computes the cash pay per month. So what is the name of our file? The name of our file is superoverride.java. This tells you that superoverride will be the name of our class. Then program implements runtime polymorphism using super keyword. The name of our package or the name of our project is super override. Then we have import java.atil.scanner. Then we have the definition of our first class, which is class payment. Now this class called payment has the following members. It has one data member called weekly pay and another one called salary, who are of type double, and another one called weeks, who is of type integer. Then we also have the methods. Now the first method here under class payment is the cash. Now this cash method as the object for controlling the input, which is of type scanner. Then from there, we prompt the user to enter his or her weekly pay. So this statement will be displayed on the screen, and then the user will be given an opportunity to type a value, which will be then by next double method, and that value which will have been received will be stored in the memory location or data member called weekly pay. From there, the following statement will be displayed on the screen, which is how many weeks have you worked? And then the user will key in a value, which will be then by the method called nextInt, and that value will be assigned in the memory location or data member called weeks. From there, the content of the memory location called weeks will be multiplied by the content of memory location called weekly pay, and the results will be assigned or stored in the memory location called salary. From there, the processor will display the next message, which is your monthly salary is. It will pick the content in the memory location called salary and display the figure at that point as new line is created. And my dear students and the rest of the learners, that will mark the end of this public cash method, and also the class called payment. So from there, we can move on to the next class. Now the next class is called amount. This is a subclass or a child class or derived class because it is inheriting the properties of the class called payment. So what is the definition of the subclass called amount? One, because it is inheriting the properties of payment, we can see, one, it has a method called cash. Now, if you look at this method, this public method called cash, and then you go back to the payment class, you can see that payment class has method called cash, but also the class called amount. The subclass called amount is also having a method called cash. But what this method does is different from what the other one does. Now, this method called cash is invoking the superclass method for cash, as you can see. Then from there, once the execution of that method is complete, the control will be brought back to this point, and the text which will be displayed on the screen is you have been paid in cash. And that will mark the end of that class or that subclass or derived class called amount. Or yes, called amount. Then from there, we have another class. Now this class is called public class super override. Now this class has the main method. Now this main method is going to do the following. Number one, through the main method, we are able to create an object called the pay, which is of type payment, meaning it belongs to the payment class. So payment or this statement indicates that payment reference but amount object. Payment reference but amount object. Then through it, we have the statement for invoking the method called cash, which is in amount a class. Once that method is completed, or once that execution of that method is done, the control will be brought back here. And once this braces any countant, that will indicate the end of that program. And therefore, my dear students and the rest of the learners, we can transfer that program, we can transfer this program into our IDE and see how our IDE or how this program will behave. So let's proceed. We load our IDE, which is Eclipse, and then we code our program. Note this, my dear students and the rest of the learners, before we code this program using the IDE. That number one, the name of the project will be super override. That will be the name of our project, super override. Well, the name of our class, the name of our class, which will be the name of the file, will still be super override. And where is that class here? Super override. I want to see where it is. This is the one, super override, the one which has the main method being part of its definition, super override. So we can proceed and decode our program. So let's launch our IDE. We click on Start button, and then we search for our IDE. Remember, the name of our project, which is the name of the package, is super override. Don't forget that, because if you don't use the correct name for the package and you don't use the correct name for the class, then your program is bound to misbehave. So how do we proceed? So you click on File menu, point on New, and then click Java Project. And then you can call this super override that way, super override. And then you click on finish. So this is so I repeat what I've said, my dear students and the rest of the learners. But as you can see, the name of our package is super override, which is the name of our project. So the next thing we need to do is to type the name of our class, and the name we are going to use is super override. And then, of course, we choose public static void main and click on finish. You can see that our program stub has been added here. So you can click on each and every specific portion of this stub and key in or type the specific code as needed. Now, because we have already discussed our program and you have seen it, I'll just copy my program that we have already discussed and I paste it here, and then we can see how it is going to behave. So I can select this code and paste my code here. Now, the important thing for you, my dear students, to note is that if you delete the stub which you have been provided for as you are loading your program, you have to ensure that the name of the package matches with the name of the project. So the name of our project is this one here, super override. So we must ensure that our name matches here too. So super override is with a small letter S. So you have to correct it. Do also the same for the class. The class, as you can see, this public class is super override. So you have to ensure that the name which you are using is also matching the name that we are expecting to use. And that name should be the name of the file. So the name of our class here is super override. So I can, if you try to replace it that way, you see that the red lines will not disappear. So it is super. Now look here. If you, my dear students, the rest of the learners, if you check this name here, and the name that we have given for our file, you see that there is some small difference. So we must ensure that the names match. So the name that we're using for the class must match the name of the file here. So it is soup override, not super. If you look carefully, you can see that this name, and the name of the file, this one here, they are different. This one does not have an R in between, S-U-P-E-R, but this one has an R. So what are you supposed to do? You are just supposed to remove that R from there so that they match. And as you can see also, The name of the file on top here is soup override. Very important. My dear students and the rest of the learners, it is important for you to know how we do the debugging. Those are secrets in debugging. And therefore, from there, we can save our program. Once we have saved our program, we can then execute it. But always remember, you should indent your program correctly, because indenting helps you to be able to know which part is where and which part is doing what. So I'm just trying to indent my program so that it looks presentable and also easier to debug. So there we go. So we have our classes there. We have the ones which are inheriting there, and now everything is done. And you can always save the changes. And then you can click on run, and then run your project or your program. So our program has executed. We are being told, enter your weekly pay. So I can type, for example, 789, then you press enter. Then the next question is, how many weeks have you worked? I can type 5, and I press enter. Now you can see, once I have done that, the program proceeds and executes this statement here for salary, and then that value is displayed. So it is telling me that your monthly salary is that 945. So once that has been done, you can see there's this message which has been displayed here. You have been paid in cash. So where has this method or this text been gotten from? It is from the amount subclass or child class or derived class, which is this message. And with that, my dear students and the rest of the learners, we have come to the end of this program. So what we just need to do is to close all editors. If you have not saved the changes, you click on save, and then you can exit from that IDE, and we go back to our learning. So my dear students and the rest of the learners, that's how you deal with that attribute or feature of object-oriented programming language like Java. You can now proceed and listen, watch, and practice part 40 of the series in which we are going to learn about Java abstraction. Congratulations, therefore, for learning part 941 on Java polymorphism in fundamentals of object-oriented programming using Java. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 40 of the series, and God bless.